Okay, calculus. We've got a problem here. It's a great problem. It's involves a table. I really think you're going to possibly get a problem that involves a table. You can see here that train runs back and forth, east to west. Okay, east to west, and you're given the velocity function. And the question is first find the average acceleration. Well, how does acceleration compare to velocity? Acceleration is the derivative or the rate of change. It's not asking for the instantaneous rate of change, but rather the average. So therefore, we have to use slope from 2 to 8. Therefore, I have v of 8 as v of 2 over 8 minus 2. And you can see that v of 8 is negative 120. And v of 2 is 100. Divided by 8 minus 2. So you get negative 220 over 6 or negative 110 over 3. Now, we are traveling, it says, meters. And as this is accelerations per minute squared. Okay, and that's our label. Important to have that label. Question B says, do the data in the table support the conclusion that the velocity is negative 100 meters per minute at some time between 5 and 8? So if you look at here, from 5 to 8, we go from 40 meters per minute down to negative 120. The question is, do we have to sometime cross over negative 100? And we do. In order to get from 40 to negative 120, you have to cross over negative 100. That's by the intermediate value theorem. Intermediate value theorem says that if you have a function that's continuous, then you have to cross over all the values. How do we know it's continuous? It says it's differentiable. And if it's differentiable, it's definitely continuous as well. So, yes, because v of 8 is negative 120, and v of 5 is 40, and, negative 100 or negative 100 is between negative 120 and 40. The mean value theorem guarantees a velocity of negative 100 meters per minute. Okay, invoking the, I said mean value theorem. This is the intermediate value theorem. The intermediate value theorem, not mean value. Mean value has to do with the rate of change, with the slope. Intermediate value theorem has to do with actually crossing over all points. Question C says, at time 2, the position of the train is 300 meters east, and the train is moving east. Write an expression involving an integral that gives the position of train A in meters from the origin station at 12. Then use the trapezoidal sum with 3 subintervals to find the position at 12. Well, we know here that position is equal to the start plus the displacement. And the start is 300 meters, it says, at a time of 2, and we're going to 12. Displacement, we do that of the velocity function. So that's how we figure out our position. Now, in order to figure this out, what we have to do is it says we have to use a trapezoidal sum. Now, trapezoidal sum in this situation, you're going 3 subintervals. So we're going 2 to 5, then 5 to 8, then 8 to 12. And you can see that these are the values that we're going to use, okay? 140, 40, and negative 120, negative 120, negative 150. As you construct a trapezoid, this is the way you're going to construct it, okay? I'll just kind of lay this out here for you. We've got 2 and 100, and we got 5 and 40. So that's our first one. So here's how you do it with a trapezoid. 2 to 5, so this has a height of 3. Then one of the bases is 40, and the other one is 100. The way we find the area of that trapezoid is 1/2 times the height times the sum of the bases. And so that's 140 times a half is 70 times 3 is 210. Okay, we're going to do another one. Looks like we have 5 to 8. We go 40 and negative 120. So 5 and 8, negative 140 to, I'm sorry, positive 40 to negative 120. So again, we construct that trapezoid. 5 to 8 is a height of 3, and then 40 and negative 120. So we got 1 half times 3 times 40 minus 120. And 40 minus 120 is negative 80. Negative 80, half of that is negative 40 times 3 is negative 120. And then we got our last one, and this one is a little bit different. We go 8 to 12. So 8 to 12, negative 120, negative 150. So 8 to 12, negative 120, negative 150. I'm going to construct that. 8 to 12 is a height of 4, negative 120, negative 150. So we have 1 half times 4 times negative 120 plus negative 150. So 1 half of 4 is negative, or is 2, and then negative 120 and negative 150, that's negative 270. So we get negative 540 out of that. So it looks like you end up with 300 plus 210 minus 120 minus 540. So this was actually a no calculator problem on the test when they gave this. So I'm going to add these two, and I get 510. I'm going to add those two, and I get 660. If I subtract them, I get 150, and it's negative because, yeah. So I got negative 150. So the train is 150 meters west of the station. Very good. Okay. And finally, problem D. Problem D talks about another train. It talks about a train that's traveling north. So a second train is traveling north, and this is the velocity function right here. We're going to draw that out. Train is traveling north. We got a train that's traveling east. The north train is, it says that it's at time equals 2. It's 400 meters away from the station. Well, we know from the problem above that time 2, this one's 300 meters away from the station. The question is, at what rate is their distance changing? So we have east, we have north, and we have the distance. At what rate is their distance changing at time 2? Well, this is a related rates problem. We have e squared plus n squared is equal to d squared. So 2e prime plus 2n prime is equal to 2d prime. 2 times east is 300. East prime, we're going to look at time 2. What's its velocity? At time 2, its velocity is 100. Plus 2 times n is 400 times n prime. Well, negative 5t squared plus 60t plus 25, that's the velocity of train B. So if we want to be able to figure out the velocity at time 2, we plug 2 in. 2 squared is 4 times negative 5 is negative 20. 60 times 2 is 120. And then plus 25. So we're going to get 125 out of that. And then 2d prime. What's d? Well, if you have 300 and you have 400, then use a Pythagorean theorem, you get 500 out of that. And then times d prime. So we're trying to solve for d prime here. And yeah, this was a no calculator problem, which seems ridiculous to some people, but we're going to make it not that bad. We're going to divide through by 2, so then all the 2's go away. So we have 300 times 100 plus 400 times 125 is equal to 500 times d. Now I'm going to go through and divide through by 100. If If I divide by 100, I get 3 times 100 plus 4 times 125 is equal to 5d prime. Sorry about that, forgot the prime. As we solve here, 3 times 100 is 300 plus 4 times 125. That's going to be 4 times 100 is 400, and then another 100, so that's 500. Equals 5d prime. So we have 800 is equal to 5d prime. Divided by 5, we get d prime is equal to 160 meters per minute. And there you have it. Good problem. The trapezoidal sum piece, very possible that you're going to come up with that option on the AP exam. So there you have it. Yeah, 10 minutes, 11 minutes. Good job.